Hey everybody, Mr. Mack here. Today we're going to do some solutions on this 6.5 practice set on trapezoids and kites. So to start off, let's just review here an isosceles trapezoid. Isosceles trapezoid has one pair of parallel sides and one pair of congruent legs. We also know that the base angles of the isosceles trapezoid are congruent. We know that the diagonals are going to be congruent, but also that the pieces inside the diagonals will give us, or the triangles are going to be isosceles triangles. So we will get an additional set of congruent angles, such as this one, and this one, and also this angle here, and this angle here. And as well as these angles up at the top, we'll know this angle, and this angle. And of course the diagonals make vertical angles, such as these two here, or these two. And they also make a linear pair. These two adjacent angles will be supplementary. So when we look at this trapezoid, TRAP here, we can see that if this is 35 degrees, this is going to be 35 degrees. If this is 20 degrees here, this angle right here, TPZ, will be 20. Okay, so if I have a triangle which I know has an interior sum of 180, let's make this a different color right here. That yellow triangle has interior sum of 180. If I've already used up 235s, which is 70, that means that this angle in here has to be 110. Which makes this angle 110 because they're vertical, which makes this angle 70 because 70 and 110 are a linear pair, or supplementary, and this angle is also 70. And then if I look at this triangle here, it's green, I've already used up 70 and 20 out of a total of 180 degrees, which makes this angle a right angle. Okay, I found a bunch of angles here. This is also going to be a right angle here. And I also know, so if this is 110 and these angles are right here are congruent, that means that these are also going to be 35 degrees. So I have everything. So let's get TPA is 20 plus 35. That's going to be 55 degrees. Measure of angle PTR. Okay, so PTR is going to be 90 plus 35. That's going to be 125. Measure of angle ZRA. Okay, that's that 90 degree angle. PZA, 110, and there we go, we got them all. And put equals here. Alright, so let's have a look at the next one, which is a kite. So let's take a look at what defines a kite. It's quadrilateral with two pairs of congruent and adjacent sides. So the angles E and I here are the vertex angles, and if I were to make a diagonal here, you would see that these two triangles are isosceles triangles. They have two congruent sides. That means that the angle where the two congruent sides meet, that's the vertex angle. Same with this other angle here, B vertex angle. The non-vertex angle, which we've got two of them, this angle here and this whole angle here, these are congruent, the non-vertex angles. And of course, it's a quadrilateral, so the sum is 360, so that's going to be helpful to us at some point. If I draw the other diagonal, we get a perpendicular right here, and one set of the diagonals ends up being bisected, but not the other. And if they were both bisected, it wouldn't be a kite anymore, it would be a parallelogram. And the other thing about the diagonal that goes through the vertex angles is it bisects them. So these are actually congruent as well as this set here. And that's pretty good. That's a lot of information right there. So let's take a look at this kite. So what do we know about a kite? The diagonals intersect at a right angle. We know that this is the vertex angle, E and I. And I think I just need to... Oh, yeah, whatever, it's fine, I guess. Yeah, here we go. I feel like I need to make the thickness a little smaller. So this is a vertex angle here too. So that this diagonal bisects. So this is congruent, and this is congruent. This is super helpful. So if this is 40, that means this is 40. We know that these are all 90-degree triangles inside here, and the sum is 180 in a triangle. So 40 plus 90 is 130. What does this angle have to be to add up to 180? And that's 50. So it's going to make this one 50. If this is 65 here, it makes this angle 65. And we know this is 90, so 65 plus what? Plus 90 gives us 180, be 25, and this angle is 25. I have all the angles found. Now we go to A through E here and answer these questions. The measure of ETS, 50. KIT. Okay, KIT is this 25 and this 25, right? So that gives us another 50 degrees. Measure of angle IST, that's 90. Diagonals are perpendicular. Measure of angle SIT is 25. And ETI, this whole angle right here, so use angle addition postulate, right? We're just going to add the two angles, 50 and 65. It's 115. Alright, that one's done. Can the parallel sides of a trapezoid be congruent? Okay, so thinking, okay, making a trapezoid here, and here are my parallel sides. And I'm going to say, oh yeah, these are congruent. Is this a trapezoid? And we say, oh yeah, looks like a trapezoid to me. But actually, if this were the same length as this trapezoid here, it would look like more like this and not have this part. And when I draw it this way, I kind of say, no, actually it doesn't look so much like a trapezoid anymore, and it isn't. So we would say, no. The quadrilateral would be a parallelogram if a pair of opposite sides are both parallel and congruent, then the quadrilateral is a parallelogram. And that was one of our theorems back from 6.3 maybe, I want to say. Say okay. Yeah. So that doesn't work for a trapezoid. That ends up being one of our proofs for parallelogram. Okay. So this page right here, we're looking, these are all the 6 through 13 here. We're looking at trapezoids. And one reason why we know this is a trapezoid is because these are midpoints right here. So we have a quadrilateral with two sides. We have midpoint to midpoint. This is called a mid-segment right here. Mid-segment. And mid-segments, so we saw mid-segments of triangles have very similar properties of mid-segments of trapezoids. These sides are all going to be parallel, and the mid-segment, so we call these the bases, the sides that are, so this is base 1 and this is base 2. The sides that are parallel are called the bases, and the other sides are called legs. So we have a relationship here. The mid-segment is the average of the bases. So we can say, I'm just going to say B1 here for base 1. So if we add the two bases together and divide it by 2, that's how we find an average. So I've got x equals 18 plus 48 divided by 2. That is 66 divided by 2. X equals 33. That's our solution. Let's use the same equation here for number 7. We have x equals 21 plus 35 divided by 2. 56 divided by 2. That's 28. So 28 is the length of that midsegment. All right, this time we are given the midsegment. X is actually our base. 22 is our other base, and 15 is the midsegment. I'm going to call it MS. So we know the midsegment equals B1 plus B2 divided by 2. Midsegment in this case is 15. We've got 22 plus x divided by 2. Okay, how do we solve for x? Well, how about we get rid of the divide 2 by multiplying it to both sides. Okay, and then we have to subtract 22. We get 8. So let's say 22 plus 8 is 30, divided by 2 is 15. That would work if we were to redo the problem. Check it. Okay. So we have some expressions here instead of just numbers, but we still know that midsegment equals B1 plus B2 divided by 2. So our midsegment is 15. Our B1 is x squared plus 3. And our B2 is x plus 7. Just divide this by 2 because I forgot that in the equation. I'm thinking something look right here. So I still have this divided by 2, so I added my like terms to 3 and 7. Divide this by 2. Got to get rid of the 2 now. We're still getting this in standard form. I just got to do a little bit more work. 30 equals x squared plus x plus 10. Now we're going to subtract 30. We get x squared plus x minus 20 equals 0. Okay, standard form. We got it right here. Now we need to factor this trinomial into two binomials. So I'm now going to have an x and an x. And we're trying to figure out the two numbers that multiply to give me negative 20 that add to give me 1. So we can come up with a list here, like factors could be negative 1 and 20. But if we add those, that would give us 19. So that doesn't work. Negative 2 and 10 are factors of negative 20. But if we add those, we get 8. So that doesn't work. That doesn't work. No good. So 3 doesn't go into 20. 4 does. 4 and 5. If we add those, we get 1. That's it. So it's going to be x minus 4, x plus 5. Then we're going to break up this into two linear equations because we know if anything times 0 is 0. So what makes this quantity right here 0? Set it equal to 0. What makes this quantity 0? What value for x gives me 0 for this quantity? So I'm going to add 4. I'm going to subtract 5. And here are my solutions. Now you might say, oh, we have to throw out the negative automatically, but not so fast. If I put negative 5 in for x here, it gives me a positive 2. And if I put a negative 5 in here for x, I get negative 5 squared, which is positive 25, plus 3 is 28. And if I average 2 and 28, I do get 15. So it does work, although we see, if we're looking at this to scale, it doesn't quite look right because this looks like the longer side than this. But, if it says, well, it's not to scale and we need all of our solutions, that could be a possibility. 4 definitely looks like it makes more sense because 4 plus 7 is 11. And 4 squared plus 3, 16, 17, 18, 19. And then 11 plus 19 divided by 2 is 15. So this 4 looks like the better solution, but we can keep both here. And that one's done. We got one more until we get some kites here. So if I call this A, B, C, D, these angles, one other property of trapezoids that we know is because these angles are same side interior with these two parallel lines, the side makes the transversal. We know that angle A plus angle B is supplementary. So that means that x squared plus 99 equals 180. Solve for x. You don't have to factor this one because there's no x term in here. So we can just isolate x. I'm going to take the square root, and x is going to be a plus or minus 9. The reason why it could be negative 9 is because if I put a negative into x and I square it, it turns it into a positive, so that gives us 81. So it's a solution that does work. Same thing with angle C plus angle D is 180. This is also same side interior. So y squared plus 80 equals 180. Square root of 100 is plus or minus 10. If I put either the 10 or the negative 10 in for y, I get 100. 100 plus 80 is 180. Notice if I add all my angles here, the sum would still be 360. Okay. 14, we got a kite. We see that these are the vertex angles here, and we know the vertex angles are bisected, and the diagonal that goes between the non-vertex angle is going to be bisected. So diagonal is bisected, and so what does that tell us? If this section is 2x minus 7 and this one is 15, we know these are congruent. This is just a very simple equation that we set up here. 2x minus 7 equals 15. Solve for x. Get 11. Look at this kite. Here are my vertex angles here. My non-vertex angles are going to be congruent. So that makes this angle 125. So how does that help us solve? Well, the sum of all the angles in a quadrilateral is 360. Which means if I add all I have something for every single angle here. I've got let's do my vertex angles first. I got a 13y vertex angle and a 9y vertex angle. And my two non-vertex angles are the same. 13 plus 9 is 22. Plus 250. Solve for y. Boom. We got an isosceles trapezoid here. Well, what did we discuss before? Let's see. Maybe something lighter. Okay. So we know in this triangle, these angles are congruent. 120, this is 120, it's vertical. What's the angle next to the 120? This linear pair, it's 60. So let's do the orange triangle. I have a 10x, and I have another 10x, and the vertex angle is 120, and what's the sum of a triangle? 180. 20x plus 120 equals 180. X is 3. Just solving. My blue triangle here, I've got a 5y, a 25, and a 60 that all add up to 180. 19. Is that right? Yeah, so if that were 100, it'd be 20, so it's one less. Okay. Let's do one more. Make another video of the proof section. Alright, so we have another kite. We see our congruent adjacent sides show us the vertex angles. The non-vertex angles are congruent. So that means this is congruent to this, which means this is 134 also. So I can write an equation. I know 11x plus 2 has to be the same as 134. Okay. So now we're looking at y's, and we can't say the vertex angles are congruent. That doesn't work for a kite. But we do know that the sum of all the angles in a quadrilateral is 360, and I have a 4y, I have an 8y minus 4, and I have 2, I'm going to write it this way instead this time, 134. So I can say 2 times 134. I could say 134 plus 134, or 2 times 134. So 4 plus 8 is 12y minus 4 plus 268. Subtract my 4. Let's see here. Ends in 6. 96, right? Yeah. $12 goes into 96 8 times. I meant to do that in okay. I'm going to stop there. It's a lot already. We'll do the proofs on the next one. But there you go. Hope this all works, everybody. Alright, check you later. Have a great day.